All right, mathletes, here we are solving equations by substitution and also by elimination. So first thing we're doing here is we're going to solve by substitution. So we've talked about equating our y's and solving these simultaneous equations when we both have them in the form gradient intercept. So substitution is useful when we have kind of two different equations. One that is in gradient intercept form, and then here we have one that is in general form. So just equating those equations isn't that simple. But what we're going to do is we're going to want to try and generate an equation with one single variable. So we look here and we see that the top equation's subject is y. Okay, so I know what y is equal to in terms of x variables and constants. So what I want to do is I want to use that equation and substitute in y on my second equation. So what is that going to look like? So I start by writing my second equation. I get 2x plus 3. So I don't want to write a y. If I can write things in terms of x, I can solve this algebraically. Well, what is y equal to? Well, I can see that y from my first equation is equal to 9 minus x. Okay, so, and then back here, I see that this equal to 21. Okay, so now I've rewritten the second equation by substituting in the first equation here for what my y is equal to, and now I have an equation that has only x's. So if I have an equation with only x's, I should be able to solve this. So I'm going to solve it by first distributing my 3 across. Okay, I'm going to collect my like terms. So 2x minus 3x. I'm going to get negative x plus 27 equals 21. And minus 27 minus 27. I get negative x is equal to negative 6. So I'm going to multiply this by negative 1. And I multiply this by negative 1. And I get x is equal to 6. So now, remembering that my solution to an equation involves an x and y parameter should be a point. I can go ahead and pick whatever equation I want to from my originals and plug it back in and find my y value. So because this one's the subject is y, it'll be easiest to solve for y if I plug in my x to the right side. So I get y equals 9 minus, what is my x equal to? 6. So I get y equals 9 minus 6, so y is equal to 3. Okay, so my solution here is 6, 3. Now, how can I verify that that's a solution to my linear equation? So I like to go back and I check it by plugging it into this equation. If by substituting in those values I come up with a true statement, therefore it's a solution. So I plug it in. So then, since this is my x and this is my y, I'm going to plug it back into my equation here. So 2, my x is 6, and I get plus 3. My y is 3, and this is equal to, well, let's see what it's equal to. So 2 times 6 is 12. 3 plus 3 is 9. 12 plus 9 is equal to 21, which is what this system says it should be. So I've verified that my final answer here is the coordinates 6, 3 is a solution to that equation. All right, now let's look at another example here. So notice here on example 1, we have a general form equation or something that looks similar to that. And notice on this other one, this one, the subject is x. So we have it equal to x here. Well, this is another good case of substitution, but instead of substituting in x, we're going to substitute, or like we did before, substituting in y, we're now going to substitute in this for our x and write an equation with just y's. Okay, so I'm going to start with the top one again. So I have 2y minus, well, I don't want to write anything with x, so now I'm going to use the second equation. Well, what is my x equal to? Well, it's equal to 1 plus 8y. That's my substitution here, because this is what was originally x there. Okay, and I continue finishing right equation 1 there, which is equal to 2. Now I have an equation with only y, so I can solve this. So I'm going to distribute my negative through my parentheses. Okay, collect my like terms, so I get negative 6y minus 1 equals 2. Add 1 to both sides, and I get negative 6y is equal to 1 to both sides, 3. Divide by negative 6, divide by negative 6, and I get y is equal to negative 3, 6, or negative 1 half. Okay, so now that I have my y value, I'm going to plug that in to this equation and find my x. So x is equal to 1 plus 8, and I plug in negative 1 half. Okay, and I get x, now I just simplify. X is equal to 1 plus negative 1 half, so 8 divided by 2 is 4, negative, so that's negative 4. Okay, and I get x is equal to 1 plus a negative 4 is negative 3. So my coordinate here is negative 3 is my x, and my y is negative 1 half. So that should be my solution. To check it, I'm going to plug it into my other equation. Okay, so I'm going to do 2 times my y minus my x. Let's see what that's equal to. 2 times negative 1 half is going to be negative 1 minus a negative is going to be plus 3. Negative 1 plus 3 is 2. And I see that matches my solution up here, so check. That is my final answer, negative 3, negative 1 half. Okay, so in our other example here, solving by elimination, we're going to choose this method in solving simultaneous equations when we notice that both of our equations are in general form. Okay, so what we're always, our first step in trying to solve these by elimination is we want to make sure our coefficients x and y are the same size but opposite in sign. Okay, so in this example here that we're going to do, we're going to notice that our y coefficients are the same size, but they're opposite in size. One's positive, one negative. So what we are able to do with elimination is when they're in this format, we can add them up vertically and eliminate those values, because if we add opposite numbers, they eliminate. Okay, so if we add these two equations up, I do 3x plus 5x is 8x. Plus 4 minus 4, those are eliminated. And 10 plus 6 is 16. Okay, from that I divide by 8, and I get x is equal to 2. Notice at this step, we have eliminated our y value. It's no longer there because they were additive opposites. So then we get x is equal to 2. Like all simultaneous equations, we need to get the final point that's the solution to, so we need the y parameter. So at this point I can pick any equation, so I'm just going to pick the first one, and I'm going to substitute that in. So 3, well, I know my x is 2, so I'm going to substitute that in. Plus 4y, I don't know my y, equals 10. Okay, so then as I'm here, I get 3 times 2 is 6, plus 4y equals 10. Okay, minus 6 from both sides, and I get 4y is equal to 4. So I get y is equal to 1. After I divide both sides by 4. So that tells me my solution here is x equals 2, my y equals 1. To check my answer, I'm always going to plug it back into the equation I didn't use to find my y value. So 5x minus 4y. So as I substitute those in, I do 5 times 2, which was my x, minus 4 times my y, which is 1, and see what it's going to be equal to. 5 times 2 is 10. 4 times 1 is 4, so I get minus 4. This is equal to 6, and that's the same as this. So check. I've verified that this is indeed my solution. One more example here. Okay, so solving by elimination. Notice that these coefficients, we don't have either of them that are opposite or the same size. Okay, we have a 3 as our x and a 4 as our x here, and we have a 4y here, 5y here. So if we add them, nothing's going to eliminate. So what we want to do is we want to multiply them on both sides by a constant, so a number, in order to get the same, to get an opposite sign. Okay, so at some point I got to decide, do I want to eliminate my x's or do I want to eliminate my y's? So if I want to eliminate my x's, okay, I'm going to make sure that I'm going to multiply the top equation and bottom equation by a constant so that these numbers in front, okay, are the same but opposite in sign. So what I'm going to do is I'm going to multiply the top by negative 4, so the coefficient here, but change the sign. I'm going to multiply the bottom one here by 3, which is the coefficient in front of my x. Okay, so by doing so, and I've got to multiply it through the entire equation. So negative 4 times this entire equation is going to be negative 12x minus 4. Negative 4 times 4 is negative 16y, and negative 4 times 14 is negative 56. Okay, so now I'm going to multiply 3 across to the second equation, and I get 12x plus 15y equals 30 plus 21 is 51. Okay, so notice now by doing that, I've not changed the equations, but I've just got it so that when I add these, my x's will be eliminated because we have opposites there. So now I do my adding of my coefficients. So we add them up and we get 0x, negative 16y plus 15y. I get negative y is equal to a negative 5 here. So multiply both sides by negative 1 because I want to know what positive y is equal to. And I get y is equal to 5. Just like we did before, I'm going to plug it back into the original equation. Let's pick the top one. So 3x plus 4. Plug in my y. My y is 5 equals 14. So I'm using equation 1 over here. Okay, so now I'm going to solve this for x. So I get 3x plus 20 equals 14. Subtract 20 from both sides. And I'm going to get 3x is equal to negative 6. Divide by 3. Divide by 3. And I get x is equal to negative 2. Okay, so I have my solution here, which is negative 2, 5. And again, I like to verify my solutions by plugging it into the second equation. So by doing so, I'm going to do 4 times my x, which is negative 2, plus 5 times my y, which is 5. Okay, and check my answer. 4 times negative 2 is negative 8. Plus 5 times 5 is 25. Negative 8 plus 25 is 17. Sure enough, that's what it is here. So I checked my solution and verified that negative 2, 5 is a solution to this system of equations. That concludes our notes for tonight. Make sure you highlight any questions and bring them to class.